a light start before we look into how we can supercharge Power BI with Azure Synapse Analytics. But this is a special event, so today we don't supercharge it. Today we enchant it. My name is Mathias Halkær Petersen. I work as a principal architect in a company in pan-European company called DataMinds in the data analytics department. I've done several stuff throughout my year. Been in the Air Force, project management, some product development. Finally found my passion in IT and in BI, and that's why I'm here today. Basically to share my passion and to talk about my two very favorite tools at the moment, Power BI and Azure Synapse Analytics. Of course, SQL is also on the list. I mean, we will probably never not have to do SQL in some capacity. Besides that, I am active on LinkedIn. So if any of you are too, feel free to connect. I will make sure to accept right away, and you can ask questions, and we can have discussions, and that would be fantastic. So go ahead and do that. And if you don't use fancy QR code, I mean, you can search for my name, so it should not be that hard. Besides that, I have my personal blog called fluxbi.com. And I also do the Power BI quiz and the data platform quiz, which is actually going to be, again, a combined of those two next week on Thursday. So you should be more than welcome to join. Very informal, very low-key, very, well, just a bit of fun in the evening when we want to talk about our passion, but not actually have to do work. Yeah, so that's me, and I'm very happy to see all of you here. I mean, this is an amazing crowd of people. I did not expect that when I woke up this morning. And I just hope that if you didn't before you entered the room, that you're going to share my passion for both Power BI and Azure Synapse Analytics when we are done today. Great, and here comes the power cord. Thank you. So, I work as a principal architect, and I have gotten a question a few times about what does being an architect even mean? And it's a good question, because it's hard to explain. But it basically means helping out clients, work out how we use the right tools for the right task at the right time, and make sure that whatever we do fits their company and what they want to do. That's the formal explanation. If you go and ask my 6-year-old son, I'm pretty sure he would say something you didn't understand because he speaks Danish. But besides that, I'm pretty sure he would tell you that his dad doodles for a living, which is not completely untrue either. But yeah, enough about me. These are the main characters of today. And I want to start by saying that I hope that when we're done today, that you're leaving with an appreciation that Azure Synapse could help you do a little bit more than what we can do with only Power BI. I also hope that you're leaving with a sense of that you don't feel so overwhelmed, or that it's not so daunting after all, that it's actually something you could get started working on if you'd like to do that. It is, so next thing, can we have a raise of hands? How many here are working with Power BI in any capacity? I assume a lot in the room. This is good. And how many in the room are already in some capacity working with Azure Synapse or Data Factory? That is a lot. I hope there will be bits of pieces of inspiration for you as well. The session is mostly focused on people from the Power BI side. So some of this may be basic for you guys, but hope you will pick up something along the way as well. Great. So in today's data realities, we have many tasks. But basically, our job is to make sure that our data becomes valuable. And to be that, we need to make sure that it's trustworthy, that people can access it, that it actually enables business insights. And of course, we want to do this faster and faster every month, every year, all the time. That's clear. And then finally, we also, of course, have some legal and compliance things we need to live up to. So that's kind of some of the goals. But if we rewind back a bit, what was some of the challenges in data? Well, even before I was even born. Well, there was a classic problem. We have business, and we have enterprise, and we have business, in the sense that we have some business department, then we have some enterprise needs, and then we have some business departments. And it's simple enough that you, for example, a finance department, they have some data, they generate some data, and they can offer this data to the enterprise. But they also need to analyze this data again themselves. And that's cool. But when we add other departments into the mix, it starts clashing a bit. Because finance have data, they can offer data, and they need data. But they don't just need their own data. They don't just need their own data. They also need data from the other businesses that they can deliver. And other business areas need data that they can deliver. And to make things even more complicated, they don't always want the data to look the same way. Sometimes they want to translate them into some specific names, or sometimes they would want to do some different cleaning or different lookups. And that can be very complicated. How do you solve the centralized data together with the flexible periphery down here? And two guys kind of came up with a solution to this problem already again. And this is something I realized last night speaking to a co-speaker. We talked about these two guys, Kimball and Inman, who basically are the two fathers of the data warehouse. And what both of us realized, that none of us was born at the time that data warehouses were born. So that was a bit surprising to me, actually, that I'm younger than the data warehouse. Yeah, puts things into perspective. So it surely has survived the test of time. It is an important pattern. But one thing was something that they at least agreed upon, and that was the fact that by having some sort of central storage, as well as having some sort of flexible business unit, they both named the data marts. Well, that is, of course, beneficial, and something we should strive upon. So that was the concept. People started finding technical implementations to kind of solve this concept. And at the time, this was done with the tools we had available back then. So it was often kind of expensive, it was often complex, and it also required a lot of central governance. All in all, it was a 100% IT, or mostly 100% IT-driven task in a lot of cases. Use tools like SQL databases, analysis service, some reporting services, a typical way to solve this. And then Power BI arrived. And Power BI completely disrupted the way we did business intelligence. Because suddenly, it wasn't just for those top 5% large companies. Suddenly, even the mom and pop store could, 5-man people, 10-man people, they could spin up a Power BI license and start working with their data. And of course, they would just do it completely themselves without involving any IT or central organization. But you also have the bigger companies that realize that, well, the businesses don't need to be limited by the bottlenecks of the central IT, so maybe we let them play with the data. So today we have this mix of companies just running completely on Power BI, companies using it partially, maybe they have a classic data warehouse, and of course also someone who also moved into some cloud data warehouse like Synapse. But but we got all this paradigm shift into much more self-service BI. But did we solve it completely? Did Power BI solve the entire thing? That's a question I've been asking myself a lot. So what we had, I think it's around 5 years ago, around 2018, this is what we had. We could load data into our data sets, could create reports based on them, and we could share it. And Power BI does all of these very, very well, incredibly well. And we could orchestrate it in the service. That's really good. Possibility to pull in the data, use it across different reports, share it across the business, and just let business users create their own thing and share them between each other. But we may have lost out on some things along the way. So what are some of the missing pieces? The first one I'd like to point out, and in some cases this has been solved, but in others the results can be quite devastating if it's not. So you have companies making data set on some sources. And then they go from making 1 to maybe making 5, to maybe making 50 or even hundreds of data sets on the same source. Some of them have inefficient queries. They load way too much data. Some of them even load the same data multiple times because, well, it's not necessarily technical users that understand exactly what they're doing behind the scenes. And most of the time, probably not even using query folding, so just loading the whole thing, even though they don't have to use it. And that can, of course, become a problem. The actual data source starts burning, but only figuratively. I mean, it starts becoming slow. It may even crash, and I've seen it plenty of time. Yeah, it can definitely crash from the load of Power BI if you just have enough going on. So, having a middle ground between all these data sets and the data source is a good idea. Second problem is that we had this kind of thing sorted. Businesses were able to hand in some data to the enterprise, and they were able to take it out again. So this was fine. There was a centralized, systematic way of sharing our data. But Power BI kind of became this loophole where we can just skip anything enterprise and just say, well, we don't need to care about this big enterprise. We'll just make what we need ourselves and don't care about the rest of the organization, which is really good for agility and innovation, but not very good for sharing your data across the organization and all the possibilities that may have led to. So different problem. And I think if we take a step back and instead of just looking at what we have in Power BI, we look at, well, what did we have in these old concepts of how we move the data through the entire pipeline. So there's more than what we can do in Power BI. There's the need to actually ingest the data and save it. There's a need to have a proper way of cleaning the data and even do some logging and auditing and even actions based on this cleaning. Because cleaning is not just about cleaning, it's also about checking the quality of the data. It's also about actually putting down actions if there is something wrong with the data. And if we just load it into a data set and ignoring all these steps, well, then we just go like, well, we don't care. We use the data as is, and someone else will have to fix it, which is not necessarily optimal. And then finally, we have curated data. Because Power BI is excellent for curating data, except only if you're actually working with Power BI for everything you do. It's really hard to actually pull the data out of Power BI. So having a curated, dedicated resource to help with actually sharing the data outside of your single system is definitely also beneficial. So this is from 5 years ago. We've had some changes since then. Oh yeah, I forgot to say. And the sharing of the reports as well also kind of locked you into to only having to use the Power BI and Power BI only. But we got the data flow. And data flow helps solve some of these things. But if I'm honest, I'm not too sure exactly which of them it solved or how it did it. I mean, it seems to be used for all of them, but not necessarily in a structured manner for all of them. But I think I've landed on it's probably mostly being used as an ingestion tool and slightly standardization tool in most places. So we got that. That was a step of the way. We also got the possibility to use datasets as a source for other datasets in the currently called feature called Direct Query for Power BI datasets and Azure Analysis Service, which is, I think, the longest name for any feature that's ever been made. But it allows us to use datasets as a source for other datasets, which again helps us by creating these curated pieces of data that can be shared between other parts of the organization and can be used to build other things upon. Then we also got the REST API. So hands up, how many in here have ever tried to load out some data with the Power BI REST API? Whoa, that's a lot. I usually get this many. This is pretty impressive. But can you imagine a guy who wants this data outside of Power BI, who doesn't know Power BI, who doesn't know DAX, who doesn't know, well, anything about it? They just want this data for some other application. Do you think they are very happy with a solution where they have to call the REST API and use a DAX query language they don't understand? Not really, to be honest. So that's why we got the data mart, because it really helps with having now a curated data set that can be now shared with something that almost everyone within data knows, with SQL. So we solved some of the things. But there's still things left to do. So we may have solved some of these points, but I think there's still something left that Power BI doesn't handle exceptionally well today. I don't like the fact that everything kind of happens out of sight, in the sense that it's a big black box. Once we create a data set or a data flow, we may do 10 steps, we may even do 50 steps and joins and everything, but we cannot audit the data of what's happening in between those steps. Not in an easy way, at least. It's not always the best tool for data warehouse task. Well, that's kind of similar to the first one. No logs output from quality checks. I said it before, we should do quality checks on our data. Power BI theoretically can set up actions based on this. It's not made to do it, it's not perfect for it, and we don't have a proper tool for handling that. And then Power BI can have problems with data at large sizes. And I do mean very large sizes. So it's not necessarily a problem for all organizations, but it is something that more and more tends to become a problem, that data refreshes take too long time, that they break because they're too long, that they just have too much data. And that is something that we can do better somewhere else. So what are the enchantments here? What is it exactly that we can give to Power BI that can help it? The first one, and I think I would say is the most important one, is the ability to do time travel, which is of course historical data and change tracking. Not to be confused with the actual data term time travel here. I've had that complaint sometimes before. I actually mean that the possibility to actually store, how did the data look yesterday? How did it look a week ago? How did it look a month ago? How did it look last year? That's not something we can do in Power BI. Every time we load in the data, we overwrite the old data. I mean, there's hacks. We can do incremental refresh, and we can do stuff like a data flow and then an incremental refresh data flow that kind of builds up this history. But it's clumsy, and it's risky, because the moment there's something wrong with this data flow, you lose this history. It's not really persisted, saved anywhere. So that's one thing where we can help Power BI, actually building up this history. And you may ask, but do we need this? I mean, most of the time we only care about what is going on right now. And I think it's a bit of a chicken and egg problem, because a lot of organizations don't realize the analytical value of looking into historical data, because they never have it accessible. So though in their mind it's like this doesn't exist, they haven't even started imagining what they could do with this kind of data. But there is a lot to do. I mean, and one of the clear examples is something like project management. Imagine you set a deadline for a project. We say, well, we want this project done in January. That's fine. January comes along. We realize, well, this will not be done in January. So we push the deadline. Say it will be done in March. And we hit March, and we finish the project maybe 5th of March. And the deadline was 1st of March. Then this goes into our data. We have a deadline column saying deadline 1st of March. We have an actual finish date, 5th of March. And everybody will conclude this project was a success because we were only a few days late. But the reality is, we were not. We just pushed the deadline. And if we had put in systems to capture what did the deadline look like when the project started, what did it look like 1 month into the project, what did it look like halfway through the project, we can actually track much more depth of what's going on around this project. And this is just one use case. There's plenty of use cases for all business areas for data history. And I think we need to create the history before we can open the eyes of the organizations to the value of this history. Second one, so enlarge. So actually all of these, except for the time travel one, are actual D&D concepts. I had someone in the audience actually check for me. She knew about D&D. I don't. So enlarge, and that is the massive scale. Power BI has limitations, it doesn't work well with very large data, but we have other tools, of course, Synapse, that can do that. Then we have counterspell, which is the D&D word for reverse ETL. So reverse ETL is the possibility to take the data from your data platform and use it somewhere else in an application, or even push it back to the source systems for enriching that data with this new context. Then we have Wish, which I've been told is the most powerful spell in D&D. So powerful that most people actually banned it from their games. So I don't know if there's the same thing here. Is this so powerful that most people don't allow it in the organization? You could argue. So the Wish here is the possibility to do multiple programming languages. You have the flexibility, not in Power BI, but in Synapse, to, if you have a problem, if you have a task, you can solve it with SQL, you can solve it with Python, you can solve it with C#, or you can even solve it with Scala. So we can start choosing the right tool for the right job, and not just go, well, we're just using SQL for all. Of course, that comes with a trade-off. More tech debt, more skills having to be learned by those working with it, but it's also very powerful if utilized. Then we have, I don't know how to pronounce it, divination, which is the possibility to actually do AI on top of our data. I mean, Power BI can connect to cognitive service and probably also ChatGPT or GPT-4 or something, not yet, but something like that. But we cannot build our own data machine learning models in Power BI. We cannot build them and then use them. But if we have our data somewhere else in, for example, Synapse, we can start building AI models, and it's ready to be used by the Azure machine learning tools. And those models, in turn, can be used within Synapse, but also be used back in Power BI after we've created it. So we even unlock some of the features in Power BI if we can build our own machine learning models. And that, of course, it's a whole different topic that could be a whole speak in itself. Finally, we have the ability to regenerate, which is, in D&D, possibility to grow back limbs. And also, I think, getting more hit points. Or restored your hit points. Yeah, someone is giving me the thumbs up, looks good. So this is, of course, the ability to restore what we have made. So source control, version history, all those things we can do in Power BI. We cannot do it very easily, and maybe not as well as we can do in a platform like Synapse. So those are the enchantments that we can offer Power BI. And the tool, of course, is, I said it many times, Synapse. And I want to start by actually explaining what Synapse is, because I think it's something that there's a big misconception about what Synapse actually is. And I've seen it a few times, that customers, we start talking to them, and they go, well, we heard about Synapse, it's called Synapse. We heard about Synapse, and it looks cool. And all the marketing buzz and everything, but then we checked out what it cost, and it was definitely not for us. It was way too expensive. We don't need that kind of thing. And the misconception here is that they go to the pricing calculator online, obviously, and they just switch on all the tools because it does that by default, and then they get a massive bill, or a massive estimate. But the thing is, Azure Synapse is not a tool. It's actually a toolbox full of very, very, very many different tools. Some of these tools are something like, what's it called? The old Azure Data Warehouse, now dedicated SQL pools. It's something like serverless SQL. It's the connecteds, it's the pipelines, it's the data lake, and it's the Spark engine. And you get all of this and a lot more just by creating a Synapse. But the thing is that, yeah, here we have it. But the thing is that they will all be turned off when you start. So, of course, you should be worried about turning on a service that is very expensive, like the dedicated SQL pool. But you should not be worried about just creating a Synapse and that you will get a bill from day one, because that's not the case. It actually costs $0 from the moment you start it. And then you start using it, and it will cost, of course, something. So it's a toolbox, and we can mix and match and use the tools for what we need. Meaning that it's perfectly okay to create a Synapse only to use the data lake and the serverless SQL. It's also perfectly okay to use it only for this should have been Spark, but for the Spark component. Or even for the integration of the pipelines only. I mean, there's no one forcing you to use all the tools. And to be honest, I don't think I've seen a single implementation where people have been using all the tools. So, it's a bunch of tools. Use them where they make sense. We talked about cost. It can be hard to estimate because we're paying for all the consumption. Some resource uses a bit of consumption here, some uses a different way. And usually to estimate these kind of things, I always encourage people to do proof of concepts and experiments and then deduct from there what will it cost. Because asking someone to actually put an estimate to this is going to be, at the very best, a guess. Yeah. And finally, if you're ever working with Synapse, and this goes for working with anything in Azure, always make sure that you have set something up around budgets and cost alerts, because you definitely do want a warning if suddenly a service is turned on that costs. I think the most expensive one is $250,000 US per month. So you do want alerts. Trust me, you do want alerts. Great. And data lake part. So data lake is just one part of this toolbox, and it's actually also a very important part because this is where we have all our data. So I stole a slide here from Pavel. I don't know if he's in the room today, but thank you, Pavel. So data lake, the advantage of data lake is that you have a great place to use as a landing zone. You follow the same modern structures that actually all the cloud providers, they're not agreeing upon, but they have aligned upon. It's very cheap, which is often an underestimated factor for why you should choose data lake, because it's like, I think it's a factor 10 cheaper than SQL storage. So it is very cheap. It has redundancy, it's good for quick and dirty analytics. You'll also see this a bit later. Performance is better, good for loading data into the data warehouse, and yeah, data can be easily consumed by modern BI tools like Power BI. Great. And we cannot talk either Synapse or data lake without talking ETL versus ELT, because this is actually also one of the major advantages that I could not find a spell name for. But the thing is, back in the days, in the classical setup, but also in the way we actually do it in Power BI, we load in the data into our data estate. And along the way, we have to decide the shape of the data. So we load in some data to Power BI, and we decide, well, the columns are going to be these columns, the data types are going to be these data types, and then we load it in. That's fine. I mean, we make sure that the data looks the way we want it to look to create our reports. So it's a really good thing. The alternative is, I would just load in all the data without putting it in boxes or without putting it into some shape, and just having it there in a data lake ready to be used by some service that can then put it into shape. And you may be sitting here thinking, well, if the end result needs to be structured, and the end result does need to be structured, then why would we just dump it in a lake and have it float around for us to use later? What's the advantage here? And I have actually a great example. So I had a client who wanted to do the very classical way of doing things. So he wanted a SQL database, he wanted to stage the data, he wanted the classical ETL approach, load in the data, put it into tables, have it very structured, and that was good. But he also needed data history. He also needed historical data. So we built up some temporal tables. He had to choose, what columns do we need to put history on? What does it need to be defined on? Which tables do we need? And all was good. We started collecting data, and we planned ahead. In half a year, we're going to look at this again and actually do a project on building a report based on this historical data. We were happy. The project was perfect. I kind of sneaked in a little component for him that he reluctantly agreed upon because he just wanted the classic one. But I convinced him. So a half a year went by. we built the solution, we started with the report, and he went like, oh, I should probably have included the changing business key in this history. So we had 2 tables, history on both of them, but we didn't have history on the key between the tables. Everything was useless. Half a year of collecting data, useless. But luckily, we had made the solution ELT ready. We had also loaded the data into a sort of data lake archive, which meant that we could go back here and say, oh, that's a problem, because we followed the ETL process, and we actually needed something else. So we could go back here to the archive and say, well, let's take the data from the archive, because we archived everything. We didn't choose there, we didn't put it into a shape or into a box, we just loaded everything down there. So we went back to the data lake, started pumping up the water, started pumping up the data, and put it into the temporal structure. Just backfilling 1 day at a time, went back 6 months ago, picked a date, loaded that data into a table, the next day, and all of that was done in an hour, because the data was just lying there ready for us. So this is a great case for me to illustrate the advantage of ELT, because honestly, if we'd done this from the beginning and just ignored this one up here, it would not have been a problem. It was overcomplicated by this, but it saved his bottom. Great. I think we've explored enough of what it is and what it can do and how it can help us. So let's try to do a quick demo here and see it in action. So I probably need to do something like this, no? Oh no. There you go, this one. Yep. So, this is Synapse. This is the home screen. Don't want to put you through how we actually create the Synapse, but to do it in like a sandbox manner should not take a lot of time. I think when I created this, it took me 10 minutes to set it up. So this is the front page. We have a home page, we have a data tab, develop tab, and an integrate tab. Those will be your 3 main tools. And then we have some monitoring and some manage as well for administration. So let's just start from the start and say we have some data. Let's see how we can load this data in Synapse, and let's see how we can start creating some data history. So we go here. For the sake of time, I've skipped some steps here for you guys, but when you go in here, in the integrate tab, you create what is called a so-called pipeline. Click new here, and you will just have a blank space here, in this case called pipeline 4. In there, you can create what is called a copy activity, or a copy data activity. Just meant to move data from one place to another place. It does what it says, so it's simple enough. Then we go here, and it needs a data set. And Synapse is actually kind of helpful. So if we didn't already define this, we have the option to add a new already from here. So we can create a new, and we have a bunch of data connectors. Similar to what we're used to in Power BI, but different connectors can do different things. And in this case, maybe we want something as simple as a SQL database. So we can click here and start creating such a data set. The data set also needs something they called a link service. So this is all maybe new terms. But just know that the data set is what it is. It's a definition of some piece of data. And the link service is a data source where you handle the authentication in. So we can go and we can create a new source where we have to then put in all these information. What is the domain name? What is the database name? Authentication and password, or use some managed identity or something else. I basically handle authentication from within here. Once that is done, then everything is ready to use. So we can go and we can create here the data set here. We can add such here like some parameters. Like in this case, I added a schema parameter and a table parameter. And this means that once I go back to my pipeline, and this is an important step, then I can define what is the schema, what is the table, and I can load the data for this one table. So this is not very efficient, all this work for one table. But we have created parameters for the schema and for the table. So right now we will load in the single table, but we can even upgrade from there and go, well, if I just need to type in those two information to load the data, I can go and do it somewhere else. So for example, something in the data lake, table storage, could even be a SQL table or a JSON file or something that just gives you the definition of what you want to load. And I added here simply in a very, very simple table of three, table of tables, yeah? Table of 3 tables where everything is defined around the source, schema, table, as well as the destination. It should be sent to the container in the lake called sandbox on the path SQL bits and for these file names. So all the configuration is handled by some metadata. That means I can, from pipelines, I can go in and look into this table storage. I can preview it here for you guys. You see, we actually load in this data. And I can then use this data for subsequent activities. Here I do it for each. It's a loop. And in this loop, we do the same thing. We load in the data, except here it's not a static value. We add a source schema from the table here. So we add in this as a variable, as well as the source table. So that now means that whenever I run this pipeline, it will first go look up this list, go run one row at a time, and it will follow the instructions and load in the data. And for where it has to save the data, it will do the same thing. For each row, it has the definitions of where to save the data. And we can even go in here and do something more, slightly more advanced, and go and add the time this data was loaded. So in this case, I just used the UTC now to say what is the time right now and convert it to a month, or year, month, and date folder names. And the file name also from the file is just the destination file name. Then I also do a copy here, which is just, I copy everything so I pull it in with a date, so we have the date for the history. But to make things simpler, I just take a copy of that data into a folder called current data. So we always have both the full history, but also a separate folder for what is the current data. It can make things simpler. So if we start this thing, it's going to do what we described. It's going to look up the table, and from there on, it's going to run this for each and start spinning up different tasks. It's going to copy data from one table, from the other table, from the third table, and after it's done with that, which should be around now, yep, then it spun up the next task where it's copying the current data. So now we've loaded data into the data lake. We have data, if you look here, in the sandbox, we have some data in SQL bits. There will be data in the folder called 2023, data in the month 3, and on the date 16. And here we have our 3 data files. Customer, sales order header, and sales order detail, as well as this folder with the current data. So always, if we use this file, we will always get the current data. Cool. So next step, we have the data loaded. What can we then do with it? We can use the serverless database. So we just go. There's a simple way if you're new to this. If you go here and find the data lake itself, you can actually browse through it from Synapse. You can find the file, and you can go, oh, we're interested in the customer, for example. So we can create a new SQL script and just say, just give me the top 100 rows. And it gives us all the code we need to load this data. Yeah. So I can run this, and you will see that I'm suddenly running SQL on top of a file in my data lake. I could even go, and instead of selecting this, I could go create view, SQL bits as select, and instead of, thank you. And instead of selecting it, it's now going to create a new view that we can use for this, with serverless SQL. So basically, we now have a view in the serverless with this definition in. This means that we can go, and for each of our files, we can make sort of a, I usually call it staging, but we don't have actually stage data, so like a raw version of the data without any logic or any transformations. Like this, we just create a view called, for example, sales order header, and we select everything. Great, and we can do that for all of them. And even when we've then done that, then we can start making new views that use these, where we start doing transformations, and we can start making some more or less advanced things. For example, in this case, which is a simple list of all our customers and the sum of their revenue. So a simple group by. And this was a step so far. We loaded in data. We now also process the data. Let's take the questions by the end of the session. We also processed the data, created some aggregations, and we can also even, I don't know if anyone knew this, can also do data visualization in Synapse. Wow, look at this. So let's try to pick maybe a line chart, category, customer column. Can we sort it? Maybe not. Anyway, there's very limited functionality here. You guys know Power BI. You know that this is basic at best. But you can export an image if you want to include it in your PowerPoint or something. Well. So that's loading in the data and preparing it for Power BI. So let's just move quickly on here. So that was what we could do in Azure Synapse. And again, we had all the tools available. We can do loading in data, and we can transform it, clean it, curate it, and we could even visualize it. So again, we have another end-to-end full stack we can use. But there's, of course, other tools that can supplement it. But of course, I mean, it's not very good at any of these things. So it would be a good idea to maybe combine it with some other tool. Can you guess? Because in reality, I think we get the best results if we combine the best of both worlds. And suddenly we can use the tool where they are best. Suddenly we can use the pipelines to load in the data that needs to be actually saved, build up history, things like that. We could use Power BI data flows for something that is just easy and quick and needs to be done. And we even have the new possibility for data marts to kind of sit there in between those two solutions. And then we could use Synapse and Data Lake and orchestration in Azure Data Factory, which just have a lot more possibilities and features than what we have in Power BI. And again, we can add a SQL to the mix if we want to do that. So there were actually some direct integrations between these two tools. So I'm just going to go through these so that you guys are also aware of them. So for the second demo, let's do that. And I don't think a lot of people actually knows this, but if you go to linked service in Synapse, you can actually add a Power BI workspace as a linked source. And you will pick the tenant and workspace name, and I'm not going to do that, but I already did it. So you will see down here it's created one of my Power BI workspaces and integrated into Synapse, which now means that I can go here to my data tab, to my develop tab, and see the Power BI workspace, along with all the reports, and along with the data sets. And I can even go here from Synapse and create a new data set. This was something I didn't know. This seems very promising, doesn't it? So let's try Click and see how it works. Oh, I need to install Power BI Desktop. Thank you. So that's not very helpful, but it does help a little bit. It does actually give me a possibility to generate a data source file from this serverless SQL I just made. I can download this. I can open this in Power BI, and it will have already have the source ready in that file. So especially for a user who's not very proficient in either of the tools, or in both of the tools, this is a really quick way to get started. So we can create a data set in here, publish it to the service. I already did that. So we have a data set here, built on the data that we just loaded in. And once we have that, we can even go and build a report. Where's my button? Report is down here. So here, for a new report. And this we can actually do from within Synapse. So we can actually go here and have the data load up. There you go. Wait, where is my data? Wow. There you go. And can start dragging in some fields. Okay, this is very slow. But yeah, drag in some fields, and we can start do some similar aggregations like before, just something like this. Doesn't need to be very pretty. Just to say that you actually can do this from in Synapse. And if you go and save this file, this report, SQL bits, it will actually save it back into Power BI. So you could have used Power BI to begin with, but I mean, for Synapse developers who just need to do a quick analysis on the data, I think this is pretty neat and handy. So, yeah, these were the direct integrations. You also, of course, has the possibility to, in Power BI, to connect your workspace to your data lake. So whatever you load with data flows will actually be saved in your data lake, which can be powerful if something is easier to load with data flow as opposed to Data Factory itself. There are some cases, especially sometimes around API, where it's actually an easier solve in data flow. So for me, that's an acceptable part of the big picture, if there is a clear need for it. Yeah, so to sum up, there are things that Power BI does excellently well. I think the speed and the capabilities of the dataset and the tabular model is unparalleled. Not even just within Microsoft, but within any tools in the market. So this is really great. And there's limitations in Power BI which it doesn't do well, but that we luckily have other tools like Synapse that does very good. Not necessarily exceptionally well, but very good at least. And does offer a lot more compared to Power BI. And of course, then we have the storage, which can kind of combine the two. So if you know how to integrate the data flow workspace with the storage and use that as a source, you kind of have one place for your data, which is really cool. Yeah, I think that sums it up. So none of the tools are necessarily very excellent at being end-to-end analytic tools, but if you combine them, you really get the power of both, and you get the synergies of both. So yeah, different architectures also kind of where you can use this. This is not so much relevant. We have 30 seconds for a quick question. Sorry for running out of time. So we have a quick question here as our guy.
Yeah, the question is about the file from, the file type from within the pipeline.
Yep.
I noticed it was saved as a Parquet. What did you do to make it Parquet?
Okay, so different file types in the data lake. Usually we work with Parquet files because they're faster and more lightweight and just better file format. Alternatives could be, for example, CSV. When you create the data set, you also have to choose the definition of the file type. So that's where I decided what the file will be. And within there, I actually defined also to add the .parquet to the file name.
So that was all.
That was all. I think we are actually out of time. So, okay, 5-second question. Is a yes, no answer?
It's the answer, I guess, would be longer. But you used pipelines for the extraction part in your demo. But you could also use notebooks, right?
Yes.
Or in 2 seconds.
No, I mean, so there is also the possibility of notebooks, but we are out of time. So thank you so much for coming, and I hope you go supercharge your Power BI with Synapse. If anyone has some questions, I will be open to do more time outside of the room and answer them. So just meet me outside, and I should be more than happy.